I'd like to show you a roadmap problem similar to what you might experience in test 3. So when you're doing these roadmap problems, you can possibly go through forwards and then find A and B and then C and D and then E, and then we could assign actual letters to the compounds at the end, which is the way I'm going to show you how to do this particular one. But there are other ways of doing these as well, like taking the compound here and trying to work your way backwards to D, for example. So one of the things that we can do first is determine what kind of functional groups we're expecting for A, B, C, D, and E, and that will help us in determining the best route to do the problem. So you can see that if we've got MCPBA here and MCPBA here, that points to A and B both being alkenes. It also points to C and D both being epoxides. So that's going to be useful for us. This is going to definitely be an alcohol group, and that's going to be because when we react Grignard reagent pretty much with anything that we've talked about, we're going to end up with an alcohol. We also know that this is an alcohol and it's got a similar reagent reacting with it, so that's more evidence that this is going to be an alcohol as well. So if we were going to work our way forward and figure out what A and B are, what we would do first is react this with H+, and we get our alkenes. And I already know these are alkenes because that's the only thing we're reacting with MCPBA anyway. So those alkenes would look a lot like this. There'll be this one. And there'll be this one. Now presently I don't know which of these is A or B. I'm going to have to get some more information before I make that determination. So we've got our MCPBA and we're going to react both of these with MCPBA, so I'm just going to put that once here. And that's going to give us two epoxides, and those epoxides are going to look like this. Now these two epoxides then are going to be reacted with those, or that Grignard reagent. And we're going to get a couple of products from that. Now one of the products will look like this, well it'll be that one, and one of the other products will be the result of treating this one with the Grignard reagent. So let's look at what we get from this specific one. Now since this is more hindered on this specific side of the epoxide, I know that the attack is going to occur here, and the product we're going to get is going to look like this. Which actually happens to match this structure over here. The other product we're going to get, we could attack this side or we could attack this side, because this epoxide is symmetric. If you look closely at it, you'll see there's a plane of symmetry down the center. So it doesn't matter which side I attack here, it's going to give me the same product. That's better. Now as I've said, I know that this product matches this one here. I can actually see that. It looks pretty much the same. Sorry, this one right here. Now we know that this product came from D, which came from B. And we know the other one is going to have to be E, which came from C, which came from A. So at the end now I can go ahead and assign letters to each of these. So this will be what we've matched up to this. which means that this will be D and this will be B. This one will be A, that will be C, and this will be the other alcohol product, E. Now the mechanisms are kind of helpful to us in determining what happens to form these two products here. So I'm going to briefly show you how that happens. So as I said earlier, this Grignard can only attack on this side because it's less hindered than this side. And there's the 2-carbon chain from the Grignard reagent right there, and then we can add H plus to that. And that produces this alcohol, which, as I said, matches this alcohol here. The other one, I can attack either from this one or from this one. It's going to give me the same product because since it's symmetric. And there's a negative charge there. And add H plus to it, and that will give us the other alcohol, which ends up being E. And I want you to see that this is the chain from the Grignard reagent there. Now part of the reason I bring this up is that if we're aware that this is the chain from the Grignard reagent and that this is the chain here, it would be possible, knowing that D was an epoxide, to work out what epoxide D actually was by working backwards from this product. So the process there would be to say, well, this is the chain from the Grignard reagent, here it is here in the product. Knowing that D is an epoxide and that the OH would be on the carbon adjacent to where the epoxide would be attacked from, and as you can see, that's sort of the process there, is that the Grignard reagent always ends up attached to the C if it's next to the C with the OH, and you could work your way backwards and figure out that the Grignard reagent, the epoxide that was D would be this specific epoxide, and that might help you figure out what alkene B was as well. So that's a useful thing to be able to do, especially if you have trouble moving forward from this point.